Hello, in this video I'm going to explain how to solve an ODE with the help of Simulink and then transfer the data of the solution back to MATLAB. I'm going to first start by opening Simulink and then I'll choose blank model to start my model from scratch, which opens a blank model for me. I'll first place text with the description of the problem just so for me to be able to easily look at it for reference. The first model I'm going to need, of course, is the integrator model, since this problem is of first order derivative. So I'm just going to need one integrator model. I'm going to search for the integrator block actually from the search bar here, and then I'll drag the integrator block. I'll click the library browser again to place more blocks as needed. I'm going to need the gain block because I have 2 times t in my expression. So I will search for the gain block and then drag it into the model. I'll also need the clock because I have t in my expression, which is the time. And I also will need the scope for me to be able to visualize the result. And the sum block because I have an addition or summation in the expression. Notice that the initial condition that's given is y at 0 is equal to 0. So the starting time is 0 and the initial condition is 0 as well. So I'm going to double click the integrator to ensure that the initial condition is set to 0. Otherwise I'll have to modify it from here directly. The next step I'm going to do is connect the clock to the gain and change the value of the gain from the default value of 1 to 2 instead, because I have 2 times t. Now I will double click this signal here and change it or add a label to it, so it will be t, just for me to be able to trace my solution later on once I'm done. So this is t, this is 2t, so the output of the gain is 2t, and I will need to add 2t with y, which is the output of the integrator. But notice that I only need to add 2 items together, so my sum block is complete. It has 2 plus signs and 1 output, but if needed I can easily modify the sum block by double clicking it and then add signs as necessary. I only need 2 plus signs. If you want to add minus signs as well to perform subtraction, this is also possible. You just need to list them here in the settings of the sum block. The second input to the sum block is y, which is the output of my integrator, since the input of the integrator is actually y prime, which is 2y plus y. The input of the integrator is the result of a summation here, so I'm going to take the output from the sum block and connect it to the integrator. And to help me trace the model, I'm going to also label the rest of the signals here. So this is going to be y prime, the input of the integrator, and the output of the integrator is y simply. If it helps, you might want to readjust things or rearrange things just to help you better visualize the model. So now the sum block takes 2t, and if you want you can also label this signal here 2t, and it also takes y and it outputs y prime. Now y is the output of the integrator, which is the solution for my problem. So I'm gonna connect it to the scope and run the simulation to be able to look at the results. Notice that the default stop time here is 10, but if you want to change that you can easily just adjust the text here or the number to whatever end value you want to stop at. So this is the result of the solution of the ODE y prime is equal to 2t plus y with the initial condition y at 0 is equal to 0. And I have the solution from time is equal to 0 until 10. Now, if you want to transfer the result to MATLAB, you need to place what's called the to-file block. So I'm going to search for to-file and then drag the to-file component or block into the model and connect it to the output y. Okay. Now, instead of the default untitled.mat name, I'm gonna modify that to a more descriptive file or a more descriptive name. I'm gonna change it to data, and then you can leave the variable name as answer, the default variable name, and the default format for the data is time series. We're gonna leave it at that. So the only thing I've changed now is only the file name. I'm going to show you two ways of doing this. First is leaving everything at default except for the file name, and the other method is to change the format to something else. The other option is an array here. I'm going to click now OK, and then rerun the simulation for me to be able, or for Simulink to generate the data.mat file for me. Now I'm going to go back to MATLAB. I'll notice that in the current folder, Simulink have created for me the data.mat file, which I can easily load into the workspace and process it as needed. I've already solved the same ODE, but using the dsolve function in MATLAB, which helps me solve the expression symbolically. I'll just run the script for you to look at the result or the solution. I've used EasyPlot to plot the result from 0 until 2. And I've also changed the title, the default title of the solution from EasyPlot. As you know, it will automatically put the title as the expression itself, but I've decided to relabel it. So it will be now the solution of the expression using dsolve. And I've placed a y label. By default, the dsolve function or the EasyPlot function will add a t label for me, or the x-axis label for me. Notice here I've decided to plot the solution of dsolve from 0 until 2. So if I want to superimpose all of my plots on top of each other, it is important that I choose the end value to be the same. This is where I'll be able to make a complete comparison between the entire graphs. So if you want, you can either change the EasyPlot so it will stop at 2, or you can go back to Simulink and change the stop time to 2 again to match what you have in MATLAB. Then you'll have to run the simulation again for you to be able to update the data.mat file. Okay, now the data.mat file has been updated. I'm gonna now type load data.mat to load the data, and then I'll run the script to show you what the output of load data.mat is going to be. So this is the result of the dsolve solution, and now the output of load data.mat is simply going to be nothing if you see the command window, but you'll see that in the workspace you've created a new variable named answer, which is the default variable name, or the built-in variable name for the most recently computed data. So if you leave the variable name as it is, the answer default, you have to specify a name for it when you want to load the data. So I will say ysim is equal to load data.mat. I'm going to simulate, or actually evaluate, only the selected part of the code just to show you what the result of ysim is. As you can see now, ysim is a structure with just one single field of name answer, and it has the format time series, and it's a 1x1 time series. So to read or to reference the field answer, I need to say ysim.answer. Now everything I'm doing is in the command window just to show you how things work here. So ysim.answer is going to display all the properties within the ysim. So since it's of type since it's of type time series, it is possible for me to directly plot ysim.ans as it is. It will automatically put the x-axis for me and the y-axis as such. So now the x-axis is from 0 until 2, and it has a label time in seconds, and the title is time series. You can of course overwrite the title as well as the x label. So this is one way to plot the result from Simulink. The second method is to extract the data directly. So let's say, for example, time is equal to, I want to read the time array from here. And the way to do that is to say ysim.answer.time. I'll hit enter, but observe the workspace. Now it's going to have a new variable named time, and it's of type array. The size of it is 51 by 1 double. Then I'm going to create another array. I will name it ydata, or data, or simply y from Simulink. It's going to be equal to ysim.answer. The data array here. Okay, now I have two arrays. I can easily plot them. Time, comma, y data. But notice here, I'm using just the plot function on two numerical arrays, so I have to explicitly mention the x label, the y label, and all of that. So this is one way to plot data from Simulink that's of type time series. This is the second method. So let's move everything to our script file so we can save it for later. So I'm going to now type whichever you prefer. I'm going to choose this method. So I'm going to copy my code, paste it here. So this is to extract the time component. This is to extract the data itself. And here I'm simply plotting them. But before doing that, I'm going to type figure to open a new figure window. And then I'm going to add the title, x label, and y label. The title is going to be the solution using Simulink. And I will need to add x label is t. Let me run it. The expected result is going to be two figure windows, such that the first figure is the solution from DSolve, the second figure is the solution from Simulink. Now I'm going to open a new figure window, one last figure window, in which I'm going to superimpose everything on top of each other. So I'll say figure, and then I'll plot the result from Simulink. And then I'll say hold on, because I want to keep the current figure window. And then I'll plot the result from EasyPlot. To help you, I mean, you might want to change the label here, or the variable name, from y to something else, such as y DSolve, for example. But I'm going to leave it as it is for now. I'm going to copy this line of code and then paste it here. So now the first plot is going to be the result from Simulink. This is the result from the symbolic solution. I'm going to now add x labels. X label is t, so x label and y label. Y label is y. And then I will have to add legend, since So instead of the Y label, let me just put legends by themselves. Legend in the correct order. Since the first thing I plotted here is the Simulink solution, the second plot is the solution from dsolve. So I'll say dsolve. And then I'll also add a title saying solution of the equation itself. Since the equation has one apostrophe in it, I'll have to replace the quotation mark with double quotation mark. Solution of y prime is equal to 2t plus y. If it helps, you might also want to change the shape of the one of the plots from the default straight line to, for example, circles, or just a dash and a circle, just to distinguish between the two. Especially if they're 100% matching, you want to find a way to look at everything, even if it's in the background. So the solution with the circle is the Simulink solution. The red straight line here is the dsolve solution. I'm gonna now add a semicolon here because I'm not really interested in reading the result for the solution as an expression here because I'm plotting it. And I will also add one semicolon here as well because I don't want to read the y-sim every time I run the script. This should give me a very clean command window with only figures displaying once I click run. So this is doing everything with the format time series. If you want, you can double click the data.mat or the to-file block, and then instead just assign it a variable name. This way, when you load the file, it will automatically create a variable name for you. It will automatically create a new variable for you with that particular name that you specify here, so you don't have to store it anywhere. But I prefer leaving the variable name as answer, the default variable name. The second format that's listed here is the array format. I'll just show you real quick from the command window what this format looks like. But first I need to click run to update the data.mat file. Now I'm going to go back to MATLAB to load the file again, just to show you what the y-sim looks like. Now, as you can see, it's a struct with a field, just one single field named answer of type double. So it's no longer time series. That means if I want to plot this, I have to know where to find the time array and where to find the data itself. It's a 2 by 51, so that means there's 2 rows in the solution. And the first row is going to correspond to the time axis. The second row is the data itself. So you can read the time as such by saying time is equal to y-sim.answer, the field answer. And then you want only the first row. So the way to do that is like this. So the first row, regardless of the column number. And then to read the data, I'll name it y data as well, just to follow with the name convention I used in the script file. So y data is equal to y-sim.answer. I want the second row. Okay, now I can just plot it. It's time, comma, y data. It should match 100% what I obtained earlier. Now, if I run the script like this, I'm going to run into an error because I've modified the data.mat. So I can no longer use this to reference the time and the data field from the y-sim.answer. So I'll have to do it the same way I just did it in the command window. So the time is going to be the first row. The data is going to be the second row in answer. And That should work if I just run it like that. So 3 figures, the first one is from DSolve, the second one is from Simulink, the last figure is from both, superimposed on top of each other. That's it for this video. Thank you for watching.